Hello, licensors here again. I'm Chris. In this video, I will show you how to use Mitsubishi RQR CPU and the Ethernet IP module to configure a Ethernet IP scanner and then connect to a TURCK IOLINK master. So before we start, I would like to explain it a bit more in my configurations. So here is the Mitsubishi side. I'm using a power module of R61P and I'm using a very small CPU, R00 CPU. And this is the Ethernet IP module that I'm using is RJ71EIP91. So for if you would like to use this module, you need to download the conversion tubes. You can just go to Google and search RJ71EIP91 Ethernet IP conversion tubes. Then you'll find it and please download it and install in your computer. It is necessary to configure the Ethernet IP network if you're using this module. And here is the IOLINK master side. As I mentioned before, I'm using TURCK IOLINK master, and this time the model number is TBENL48IOL. And before this introduction video, I also will introduce the rep server and some features inside this module is very helpful for you when you do the commissioning in the commissioning step. And in the first port, I'm connecting to a module IOLINK to an analog to IOLINK converter. So in here, it's connecting a Euro switch level sensor. It will output a 4 to 20 milliampere current. Then I will convert it to IOLINK signal and then go to port 1. And here I'm using a TURCK sensor that will detect the angles. And here I say magnetic is a magnetic value test for me to that support IOLINK interface. And this is port in the port 1, 2, 3, 4, 5, 6, and for port 6 I'm using a IOLINK hub is supported by module, and in the port 8 I'm using the CONTRINEX sensor that is also supported by CONTRINEX Japan. So before we go to the programming, I would like to introduce a little bit more about the Ethernet IP I'm using this time. For this time, I'm using a Joseph owner. So the input instance will be 103, and the output assembly instance number is 104. That for the instance 103, it will have 346 bytes. And for the output, we will have 262 bytes. So here is just a table for instance 103 and 104. Maybe it's very small, maybe you can not see it very clear. And in the instance 103, that you have the input data, you have the status work, you have the input data value, and you have a IOLINK of each port, and then you have the diagnostic data. And for the output, also same that you will have the output data, the output control, and also the IOLINK output data. Okay, I think the introduction here is enough. Now I will start to open the camera, and then to other camera, and then to introduce the hardware again. And then we will start the programming. Let's start. Okay, here is the real hardware that we are connecting in this tutorial. And I'm sorry that because the Mitsubishi PLC connecting to the other place, so I'm sorry that I cannot show in here, but the network cable is connected from this green one. And here is the TURCK IOLINK master. The yellow one is the 24-volt DC supply. And for the each port, I'm using the M12 connectors to connecting to the sensors. For example, this one we are using the module IOLINK analog to IOLINK converter, then connect to a level switch that is come from Euro switch. And in here we have a TURCK sensor come from TURCK, and here you have a smart value that come from NASA's, and then here is a modules IOLINK hub, or this is connecting just from plug and play. So it's very great for some people that like me. This isn't very good for wiring. So I think the basic instruction here is enough. Yeah, and the IP is set in this window. They have a free rotator switch, Then you can reference the menu. Then you can use this DHCP mode or standard IP mode. But in this tutorial, I'm using standard IP mode. I just rotate the IP switch to configure my IOLINK master to IP 192.168.1.134. Okay, I think the instruction here enough. Now we can start to use GXLOX3 to configure up to create a project. Okay, now we open the GXLOX3. Then we can start to make the project. Then first we will create a new GXLOX3 project by project new, and then I'm using our 00 CPU and my program language I'm using is ST. So just press OK to create my project, and I will OK and save it. And demo 4 and OK. Great. Now we create a new project. The first thing we need to do, I would like to create the module configurations. Click to here. In default, there is my R00 CPU is created in here. So what should I do in here is I need to insert our modules. The first one, I would like to insert my rack. So here's my rack in here. Then I will drop my CPU inside here. Then I will insert my power module. It should be this one. Drop it here. Then here is our main characters. It is a Ethernet IP module RJ71EIP91. So drop in here. Oops. Great. Okay, now our conversion is finished. Then when you click here, then you see the start XY is from 0000. It means the control bit and the status is come from X00 and Y00. But don't worry, we will not use this one because we will use the label. Okay, so we can save it. And then, okay, great. Now we can compile the project at one time to make sure there's no error. The first one, I would like to insert the module of this Ethernet IP module. Then go to module and go to module label. Then here is 00 RJ71EIP91. So what we need to do here is right click it, add module label. Then the AM plus global label list is inserted in our project. Then we can open it. Then say EIP91_1. So we can just drop here a little bit more. Okay, and then show detail setting, and then plus assign. You cannot change it, but you can see what inside that GXLOX3 is very good. They assign all the XY that you use of this module, but also the buffer memory. So we don't need to care what X or what Y we are using. We can just use the EIP91_1 global label. Okay, then we can open it. You can save it. Then we need to set the IP address. So before we set the IP address, I would like to show you that I'm using the connection is here. Then again plus PLC module. The IP now is configured to 192.168.5.39. So I can press test button. Now it's successful connected with our CPU. It means that the connection is okay. So I would like to set the project. The IP of my project is same as 5.39. Okay, go back to the notifications, and then go to open the R00 CPU, and then plus module parameters. Then here is the page for you to set the IP address. Drop into here, just 5, and then plus here is 255.255.255.0, and then if you check it, there's no error. Then we put apply. Great, we finish, and then we need to set the IP address of our Ethernet IP module. Go to click this one, and here is a field for you to set the IP. Double click. Then 192.198. In this case, you set 142. Then for the IP address, 255.255.255.0. Then we can check is there any error here. Okay, no error. So okay, check again. Great, everything's finished. Then you save our project and then compile again. Okay, then the basic conversion is finished. Now we can start to configure our Ethernet IP network. For do this, we need to latch the Ethernet IP conversion tubes. When you open your Ethernet IP module, then you directly click on this icon. The Ethernet IP conversion tubes will be latched if you installed. So here is my screen that I already configured my Ethernet IP conversions, but I'll show you how to do this. The first one, you need to import the EDS file into the library, or you can use generic EDS file. But if the manufacturer provide you a EDS file, it's better to use this. It's very easy for you to integrate it. It's not, you no need to configure all the parameters. Okay, so how to do this? You press add button and next. Then you download the EDS file from the TURCK homepage, and then to choose it, and you can install your EDS file. Then after that, then you will find device library, Ethernet IP device, and TURCK. In this conversion adapter, there's so many devices in here. So maybe you cannot directly see the model number of your IOLINK master, but for the TURCK, they display the device by using order number. So in my case, my device order number is 6814082. So what do you do? Drop this one and drop it here. Then when you drop here, then you need to config. The first one, you need to activate the configurations. Then here's the connection number. It's 1. It's a very important number that when you use the function blocks provided from Mitsubishi to get the data. So in this case 1, so mean that I'm using the connection 1. Then here is the network parameters that only you need to set is the IP address. Is in my case is 192.168.1.121. Okay, then you go to connections. In default, exclusive owner is installed in your network with using instance 103 or 104. So if you want to change it, they can change it, but in my case, it's okay. Then it's enough. Then you can go to online, purpose this small green box, and then you can download the configuration in your to your modules. Okay, then after you download the project, the configurations to your Ethernet IP module, then you need to reset the power, and then you can double click here again, and then go to online parameter. Then you can synchronize to make sure that all the parameter your connections between Ethernet IP, at least your Ethernet IP module can see the TURCK IOLINK master. For example, here is the module information. You can refresh it, then you can see what products I'm using now, and the series number, and the firmware version, and the vendor ID, etc. And also for the port conversions, you can get the value. You can do the same things, very easy. Okay, so the conversion is finished. Then we can go back to GXWorks again. Okay, here is my GXWorks project in here. Then I'll close all the files, and I can start to make the program. The first one, I would like to add some structured data types. And if you use Siemens or backup for cooked this before, it's very similar to it. You can maybe you use it before. It's a very convenient components for you to group up different of variables into a structures. Then Mitsubishi also support IC611313, so they support the structure types in some deep level. Okay, so the first one I would like to add is the instance 103, the input data of the TURCK IOLINK master. DUT BDEN L4 and IOL and instance 103. Then I can just press OK. Great. And then we can go back to our slide. Here is our slide. Okay, so here is the modules we are using in here. Then when you open, here is instance 103 that we are using this time. The first we have status works, we have the input data, then we have the process input data checking. And then we have the six work of data per port. So I will create from here to here first. Then let's do it. First one is W00 status is the, I think it's the ADUS work. and then W01 is input, and then W02 is DVS. All this is data type of works. Okay, great. Then I will use the port data, define the port data, port 1. Then port 1 you have 60 port data for works, so I will press here. I create a array with 60 components, 60 links, then with work data types. So done. Then I can just copy to 1, 2, 3, 4, 5, 6, 7, 8. I will copy from my Excel file because I export this to the Excel file used in this tutorial. Then great. Now I create from port 1 to port 8. Then we can do create the next part. So after that we have the VAUX. We define the error and also the DXP channels to define the errors. So we do here same. So what we do here is VERR and DXP. Okay. All this is also with work. Great. And then we will have in the top there you have the IO port diagnostics from port 1 to port 8. They will show some detailed informations of your IOLINK port in conditions. So we define here also. What you do in here is DIAG diagnostics, DIAG how spelling NOSTIC. Oops. Port 1. Then with a work data. Then we can just copy from my Excel because all the will be same. Great. Okay. Then finally, what data we will have is we will have the IOLINK UN from 1 to 16. We have 16 buffer of IOLINK UN data. So what can do here is IOLINK UNs 01. Okay. So for this one, because each UN have 2 works. For the first byte is codifier, and then the port data, and then the UN code. So what you do in here is I will define a array again, 16. Okay. No. It's 2. Okay, 2. Then with work data type. Great. Then what we need to do is I will just copy from my Excel again, and then paste in here. Oops. Okay, great. So here my instance 103 is finished. Then I can compile again. Great. Then the next one, I would like to create the 104 instance for the output data. Okay. So here's the output data. Then we can open the slide again. Here's the slides for this instance 104. Then we will have the first work is not used. Then we have output. Then we have process output data. Then we have VAVX12. So what we're doing here, just define the same things. W00 not use. W01 DXP. For this is always work data, so I can just define its work signed. And then we have port data, port 1, that with 16 works of IOLINK data. So I will choose work sign and array 16. And then I'll just copy from my Excel again. There's no need to create hand typing here. Then we create the port 1 to port 8 data. Then finally we will create a VAUX data. Okay, great. Then we done the input, instant input and instant output. Then we can compile again to make sure no error. Then we can close it. Great. Okay, after that we will create some data type that inside the TURCK diagnostics informations. The first one is the DVS. So open the slide again here. DVS is from here. So it will have to check the input data is okay or not. Then you have 0, 2, 4, 6, 8, and then 10, 12, 14. Okay, then we can just create the same one. Add data type call DUT TURCK 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 DVS. Press OK. Then we can create a DVS0, DVS0, and then DVS2, just something like this. I will not create all this, just copy it from Excel. Then put the bit, so I create a DVS data type. After that, I will also create a VAUX data type. So for the tag in VAUX is here. Okay. Then we can just open, create again. Let's call DUT TURCK VAUX. Okay. Then we'll B0 for the first one is B0 VAUX1 pin1 C0. Then this defined as pin because we're seeing here B1 C0 channel 1. So just what I put in here. So I will just copy from my Excel again and then to paste in here. Great. Okay. Very cool. Let's compile, make sure no error. And then I will create a data type for the IOLINK port diagnostics for each one. And just open my slide again here. Then you will see having here there has 8 of works that will represent each port, the error inside. Then you can just also, for example, port 1 underscore PPR, port 1 underscore CFG error, something like this. But if you have 8 port, you want IOLINK master have 8 port, then if you're using 10 or 20 IOLINK master, I think it's not very smart methods to define it one by one. So I will just create data type to group all this data inside. Okay, let's do it. Okay, right click, DUT, TURCK, IOLINK, port, DIAGNOSTICS, diagnostics. Great. So inside just type same informations, B0 not use as USED. Okay, B1 BBR and B2 is CFG error. And okay, I just copy from my Excel again. There's no need to type it all by hand. And then to make sure I create all the data type, in here, if no error. Okay. After that, I would like to create the data type inside the qualifiers. So when we open my slide again, I would like to go to the last page, go to this page. Then each IOLINK events have a qualifiers. So the context of the quantifier is standardized in the IOLINK specifications. So here is there's some screenshot I take from the IOLINK specification documentations, and here you see the first 3 bit is for instance, and then the 4 bit is for source, and then type, and then mode, and then each items with their own meanings. For example, the type you have notifications, warning, error. For the source you have device or master something. So I will define all these data types inside. So I'll do this. Add data type, DUT, IOLINK, event, SQ, EVENT, SQ, QUA, LIFIR in the identifier, instance, STANCE. Okay. Let's open it and then close other, close inactive, save it. For the first one, you have a B unknown, BUNKONW unknown. Okay. Then you have B not used. Then you have B applications. Then you already put bit data type here, copy, done. Then I would like to create one after for instance. For example, because the instance unknown applications or not used. Okay, then next one I create the source. Source here I have device or master. So I just add data here, and then I change the name to source URCE. Okay, then for the source I will put a B is master, B is device. Then it should be bit data type. Okay, then I'll copy this one and then right click, add again. After source I would like to define the mode. Okay, so what is the mode? Mode is here. Is you have device single shot, device disappear, device appear, or not used. So it's one same in here. B not used. Okay. And then we have B event single shot. Then we have B event disappear, DISAPPEARS. Then we have B event appears. Oops, I spelled this wrong. Oh my god, APPEARS. And all of this data is defined as bit data type. So just copy, paste, done. And finally, I would like to define the type. Type is from here. They have 0, 1, 2, 3, notification, warning, error, or not used. I will copy the data type name and right click, and then do again. So it should be a type. Okay, so and then same one, B not used, B B notification, the NOTIFICATION, notifications, and then B warning, and then finally B error. Okay, all this is common bits. Just copy, paste. Great. Then we would like to create one more data type. It's called codifier. Yes. Well, ours one more. But okay. So what is this data type? I would like to group this for data type in one. Then what we'll use in here is you have instance, right? Instance, DANC. Then you have source, SOURC. Then you have a event type, right? Then you have a event mode. Then you need to open it. Then you can choose event instance, event source, and then event type, and then event mode. Oops, event mode. Okay, so check again. Instant, source, type, mode. Great. Then we compile. Okay, and we create this codifier. Then I would like to create a event data types. So event data types, open the slide, submit. Event data type, you group the port codifier, event code, and the codified data that we defined before. So just right click, add DUT, TURCK, IOLINK, event, EVENTS. Okay, inside what you have a port value. Oops, you have a port value. Then you have a codifier, UA what? LIFIR. Then you have a event code. Okay. Then you have a details. DAILS. Okay. For the port, that should be inside the integer, and then for the code finder is same, and then for the event code you can use sign, it should be okay. And then for the details you can use code finder. Great, done. Then you can compile again, save it, compile it, and then the next one we could like to add a data types for our module. IOLINK IO half one. The order number is 59719. Press open. Then we will open our slide again. Here is the data, the module IOLINK half they're using this time. You have 2 bytes input and 2 bytes output that represents the input data or control the output port. So I will not just copy it from my Excel because there's no need to hand typing here. Great. Then make sure I have 16. Okay, that doesn't miss anything. Great. Then I would like to create a sensors data type for the CONTRINEX smart sensors. CONT, how to spell CONTRINEX? CONTRINEX. And smart sensor, I think it's IDWE sensors. Yeah, as well. Okay. Then for the sensors, what we have is we will have sensors here, sensor here. Then we will have 4 bytes of data. The first byte is the status, then we have scale value, and then we have measure value. Okay, so again, let's do it. For the status, we have alarm 3, 2, 1, SS2, SS2, SSC1, TTSS, OSS2, OS1. So I will directly copy from my Excel. I don't need the hand writing here. Great. Then we have a R32 is a real data scan value. Then we will have a R22 measure a SURE VALUE value is both of its a real data. Okay, it works. Then all the data type I think is finished here. I will compile it, make sure no error. Then now I will start to create the functions. Close all, save it, and by using functions, you should create inside this fb/fun folder. And by the way, function is different to function blocks. So if you don't know how the difference between function and function blocks, I hope you to go to search function block trinket, and you have a very great YouTuber to explain fully what is function block. Actually, all the pairs is same. Okay, so create function here, add type. Then you can choose function in the job list. Then you can enter the function names. In my case, it's TURCK get events. So I will encode the event data inside these functions. And then the language in here is ST, and then you choose the return type. So what is our return type is events. Okay, and press OK. So as I show you again, event is all data that are green here. So we should return a very great data structures. Then let all the users know from I think here. Okay, all the informations for each port. They will not just return some red byte. Okay. I'll go on the local label. The first one you would like to find the input data. Input data is iData. It should be 2 array of works. So I will define a work signed with array 2, and then you can change the index even what you like. After that, I will drop this the input, so it will be input data. Great. And then I will define some BENO and then also some temp work for me to use inside our program. It should be bit in here. Okay. And then we will have a 60-bit in here. Okay. No need. I don't need this screen. Okay, great. And then just oops, compile again. Make sure no error. Then we can start to make the program. Okay, for the first one, I would like to get the qualifiers. So how to get it? I'll use the and work and instructions. It should be true. The first one is true, no and yen, and then NES one is this the source. It should be iData, the first one, and then S2 is what data mask or what data they will need to operate with a N instructions. In my case, is 60 sharp 00 FF, and then I will put it back for the return value of fb.TURCK get event dot details dot no not here, sorry, dot q qualify this. Great. So why I need to with have a mask with 60 with FF, because okay, I open the slide again in here, because FF is here, so I don't need the port details. I will just leave this qualify the value. So here's the work, and I will take out this this byte and just use this qualify the bytes. Okay, and then I will take the port data also. So how to do this? It should be on, also be true, data iData 1. This time it should be 16 FF00, and I will put it to a time work. Okay, and then time work is equal to SHRE. Is it a work shift instructions? It should be true. What's that? PENOP. What I define? PENO 10. Okay. Any bit in, it should be 10 work, and then 8. Okay, it should be port. So what is that? Open the slide again in here, because the port is in the next byte, so we need to take a mask to take out this data, and then just shift it 8 bits, and then to make a correct values. I'll say that like this. And because Mitsubishi, they cannot process the byte data, so that's why I need to do this one. So here is okay. I get the time value. So what I need to do is I can fc TURCK.port is equal to 10 work. Okay, great. Then I get the event code. Event code is I'll get the event code. Event code is fc TURCK.event code is equal to what? Is equal to iData second one. Not big deal, right? Okay, I think I finished the first part, and then we need to put a time work is equal to quantifier. Now we need to encode what inside the quantifier. Why I don't have it out? Okay, so after that we will insert all data first. So fc TURCK.get event details event mode appear is equal to false, and then fc TURCK.details disappear is also equal to false, and fc TURCK details event mode single shot is equal to false, and FC TURCK details UMO not used equal to false. Okay, and then the next one, FC TURCK dot details dot event type dot B error is equal to false. FC TURCK dot details dot event type dot notification is equal to false. FC TURCK dot details dot type dot not used equal to false, and FC TURCK dot details dot event type dot warning is equal to false also. Great, and then we can do the next one, FC TURCK dot details dot instance dot applications equal to false. FC TURCK dot details dot instance dot not used equal to false, and FC TURCK dot details dot instance dot unknown is equal to false. Okay, finally we need to insert the source also, right? Source dot device equal to false. FC TURCK dot details dot source dot B is master equal to false. Great. Okay, and then if it's equal to more than 0, okay, it's very important. More than 0 means the qualifier has some data inside, so we need to process. For the first one, I would like to use the AND instruction again. It should be true. Okay, true on TURCK, and then use do sharp 1 2 3 4 5 1 1 1. Okay, and then TURCK 2. TURCK. It should be TURCK. No, I think I have other one. Just a second. Let me go here. Oops. Okay, same. Okay, TURCK 2. Okay, great. So as told before, it's the AND instructions. Then true. The source is TURCK. I have a mask with 0000111, and then the data we transfer to TURCK 2. So why I need to take the mask off here? Because when we open the slide again, go to the last page. It is the IOLINK specifications. For the instance, then we only use these 3 bits. So we will take the mask with 000000111. Okay, very clear. That's why here 00001 0000 and 0111. Great. And then we can use the case statements. Case work to int. It should be TURCK 2. Okay, of and case. So what kind of data that you have here? You have 0, then you have 1. So for 0, FC TURCK dot details dot instance dot unknown is equal to true. Dot B unknown is equal to true. Great. And then for the 1 to 3 and 5 to 7, FC TURCK dot details dot instance dot not used is equal to true. And then for the 4, FC TURCK dot details dot instance dot B applications equal to true. Great, is what we need to done here. Then finish, and then end case. Okay, so after that, I would like to configure the source. Let's copy. Let's put it here. Put a slash here, and the source WAN var word and operation again. True TURCK and 2 sharp. This time will be 0 0 0 0 1 0 0 0. Then you transfer the timbre 2. Great. Why we need to 0 0 0 0 1 0 0? Because let me open the site again. We are using this bit, so it should be 0 0 0 0 1 0 0 0, and then we will shift it to here to make it easy to use for us this inside the program. And then you use timbre 2 is equal to SHR E true, and then B tem, and then we have timbre 2. Then you like to swap and then we try to swap phi. I think phi is enough. Okay, right, great. And then we'll use the case statements again, so I just copy, no need to handwrite again, and then make it beautiful here. You only have this device and its master, so the source is device 1 for 0, device is true, and if it's 1, so I did it here from here, dot source dot is master is equal to true. There you go, I'll delete this one, no need to use. Great. And then I would like to configure the event type. For the event type here, slash copy using the AND statements again, true, timbre, source timbre, and this time I would like to give a mask for 2 0 0 1 1 0 0 0 0, and then timbre 2. Okay. Why we need to shift to here? Because in here 0 0 1 1 0 0 0 0, and then we'll shift it to here 0 0 1 1 0 0. Okay, then we will use the shift bit function again, SHR E and true. First one is true, and then B E N O tem, and then tem, and then true tem 2 timbre 2, and then shift 4 times. Okay, and then here is same. I can just copy and paste to here. Great. 1 2. Okay. And because this one I forgot what was this one doing. Type, right? Okay, so type details dot type dot for 0 is not used, so your use is equal to true. And the second one dot notifications, and then if 2 I just copy, I think I copy here. Okay, make it a bit beautiful. Okay, and if 2 is warning, and then finally it should be error. Great, and here is 2, and here is 3. Save it. Okay. Okay, finally I would like to get the I think it's mode. I will do the same instruction here again. Use the N, WND, true, timbre, and this time what I will need to shift 2 sharp 1 1 0 0. Oops, 0 0 0 0 0 0 with timbre 2. Okay, why I need to here? Because 1 1 0 0 0 0 0 0, and I shift it to here. And then timbre 2 is equal to SQL E, and the true BENO tem, BENO tem, and then be a work 2, and then I'll shift 6 bit. Right? Because 1 2 3 4 5 6, right? And then just copy here and then paste in here, and then make it to be beautiful. Okay, you also have 4 choice in here. The first one is delete this one. Dot mode. Dot the first one is not used is equal to true. Then for the second one, it should be delete this one. dot B, I think single shot, and then for the next one is B disappear, and then the last one it should be B appear. Okay, great. I finished these functions. You can have to encode and return all the code, and then compile it. Great, no error, I hope. And then I'll also create one more functions. Here is FC. I would like to get the IOLINK diagnostics information from TURCK IOLINK master. Get IOLINK diagnostics. Okay, I create in SD. So what will I return here? I'll return this one. Okay, so I'll show you what to define here because I use this one, right? So this one should be these informations. Okay, great. Close all the data I do not want to use, and then open the label, and then define some data in here. The first one is the input, the second one is a buffer. Okay, the first one is work, it's work sign, and this one is not unsigned. Because now it's not need to swap, but by case if you need to swap, that you can directly use this swap this one. Okay, so close the one and open my project. Then first one is iPod data 1 is equal to iPod data. I need to change to work. It should be iPod data. Great. Okay. And then we can return all the data. Get IOLINK diagnostics 0 is equal to iPod data 1.0, right? And then all others is just paste. So I don't want to do too much in here. Okay, so just make sure that I didn't make any error. Great. Okay, from 0 to F, and I can combine it. Make sure no errors. Great, no errors. Good. Okay, so we can create the main program now. But before we create the main program, I would like to add the library from the provider from Mitsubishi for us to easily access the data with Ethernet IP. It's when you go to the module, I think it's a module, right? It's the module. So let me open it. Module. Okay. Open modules, and then function module FB, and then RJ71EIP91, and here. So then you can add inside, but I don't know why it cannot. So I can maybe add the function here. Okay, and then not use, and then I can add the project. Okay, I can delete this one again. I hope Mitsubishi will fix in some versions, because I think this don't make sense. Okay, anyway. Okay, rebuild, no error. You can see some of data type and function block and functions are made up in the blue color because it's still not used in your project. So it means that it may not work. The compiler actually will not check of your project. Not check of these functions until you use it. So here's the main project, main program. I would like to create some data first. The first one is B start to com. It is a trigger bit for me to trigger the Ethernet IP communications. Then we'll have a I step is for me to step for case statements control, And then I would like to define the function block instance. It should be the get data, and we name it a beautiful name. It should be FB get data. And then I would like to define some temp stuff for this function block: be yellow, be OK, be error, and u error ID, and u status ID. Okay, for example, the first B is bit, and the UID is unsigned 18 bit. Okay, great. And then I'll have a UDS, UDT, VDS. Oops, UDT, DVS. Come on, VDVS. So it is help me to get the data, check the data is can use or not from the TURCK IOLINK master. So how we use this one? I will use the DVS that we defined before. And then okay, and then we'll use R32 port 1 current and R32 port 1 level. This is the Europe sensors that we use in this case, so I just put it as a view data type. And then I think I would like to use some temp if in case, so I define temp here. And then I'll use the port 4, right? I60 port 4 process data REV, and then I60 port 4 process data. Great. Then this one is work sign, so this one is no sign. Okay. And then I have a scale, right? I60 scale. I think it's port 4 scale. I60 port 4 scale. And scale, it should be work sign, I think. Okay. Okay, I think it says enough. Then we will have I think I should define a temp for some function is not used just for other functions, not for these function blocks. So this should be bit also. And then we will have I would like to write data to the adapter. This is TURCK IOLINK master RIS Ethernet IP. So I would like to define function block for write set the output data. Then I would like to rename it nice name for my instance. Save it. And then I will have a PWM set point. This set point should be inside the work 16, so it's here. And then we will have a Moodle 559719, right? Yes, inputs. And then we will have a outputs. This is the IOLINK hub that we connect to the port. OUT right? The data type should be Moodle here. Moodle, where's my Moodle? This one. Great. Then copy. I would like to create 2 timers for me. For create a 1 second pulse. Also you can use a system flag, but I would like to use timer. I will show some other ways for you to use the function block inside Mitsubishi. Okay, T on, finish. And then I would like to create data types for my CONTRINEX sensors. So how to spell CONTRINEX? I always forgot it. CONTRINEX. Okay, RINEX sensors. This one. It should be CONTRINEX sensors, IDV sensors. Great. And then I will have I connection. I would like to define my connection numbers. It should be unsigned 60 bit, I think. because you will not have -1, -2 in here, this case. Then I would like to define some data types for me to use VAUX to get the informations of Moodle touch Moodle outing master, TURCK outing master. So it should be VAUX, okay here. So we have DUT, again, error. I think it's V error. Why cannot press the, okay. VERR, okay, it should be same. And then what we will have a TURCK port, Diagnostics, DIAGNOSTIC. So we have 8 ports. So I would like to create a array of structures. It should be diagnostics here, right? 8. Okay. And I would like, we have 7 port 1 to port 8, so I'll change the index to be image bit. And then we have a TURCK, TURCK, TURCK port event. They have 16 events, but I think I will not use 60 all, so just be 4. Actually, in the program, I think I'll use 1. Event, this one. I think I'll use the events. And then change it, the index 1 to 4. Great. So we can try to compile. I hope no error in here. Oops, error. Why? Here. Okay. Copy, paste, and then compile again. Great. Why if duplicate? Okay. So delete this one. Great. The 0. Okay. Save it and copy again. Save. Compile again. Great. And you see some of your data type is changed to right color, the text. It's because you're using now in your project, so the compiler will compile your stuff in this type. It may be a little bit strange, but in some way it makes sense. No need to compile something you don't use inside your project, right? Okay, now we can start to create our project. It should be a little bit long time, so let's go. Here's our main project. I would like to slow into it more. Put some space here. Okay, the first one, I would like to configure our connections. Connection, CONNECTRNS. Our connection number is here is fixed to 1. Why is 1? Because you set 1 here, right? And open here. If you set this one to 2, then you set it to 2. Very easy. But very easy to make the mistake. And then we would like to create a 1 second pause. How to do it? I would like to call the timer, and I would like to use this display template functions. Then you can directly get the what parameters you need to use for this function or function blocks. For the in is not fbtque.q, and tp I would like to just put 1 second. Then I don't need to use Q and ET. I just comment out it. Then you can try to compile it. Great, no error. Good. And then we have one more timer, right? And then just do the same thing. Display, template, and then just put in here, and then put in here, and then comment out this one. For this one, it should be dbt on 1.q. And then I think 1 second is enough, right? So put t sharp 1 second. And then, okay. Then we can start the communication. Start to communication. How can you start the communication? I just make some very easy conditions. B start to com is equal to EIP91.B status. Why? B STS S. Okay. B status module is ready without any error, and not EIP91.B status error. Ready and without error. It's very easy. Then we can start the communication. VIP91_1 dog B, I think B set, right? B set communication. B set communication startup request is equal to B start to com. You can directly use this condition, but you make your logic very long and not easy to modify. So I will use this B start to communication, B start to com flag here. And then we can now use this the case control. Okay. And if I60 step is equal to 0 and B start to com, then put the end for it, and if okay, so what I will do in here, I will put I60 step equal to 10. Easy. And then we use case control, case for what? I60 step off and case. Okay. Then we have 10 and 20. For the first one, for the 10, what I do, I would like to use the get input data. There's also so many parameters, so I'll use display here. Then I can fix it one by one and just put some here. I think the other one is here and here. Here, go back, and then here, and then here, and then probably here. Great. And for the I, it should be B start to com, and the module is EIP919. Connection number, it should be I connection number. For this one is a BENO. Okay, then this one's BOK, BOK, and this one's B error, and this was our error ID. So right? I say it's U error ID, right? And then U status ID. For this one, the input data start from D100. And here it's finished, but so we need to configure this D100 to point out to our instance. Point out to we need to use for example D0, D100 is equal to first status work, B101 is equal to something, B02 is 102 is equal to something. How to do it? Then we can go to the global label. You can choose the data type as structures. For the input is 103, output is 104, so we define 103 first. And then you can pay a good name to him, to that. IOLINK what? Oops, what? Why? IOLINK one 103. You can make some more make sense name, but for me it's okay here. Then you can show detail setting. There is the assign. I put D100 here. Then you see all data automatically assigned inside. And how can you check this data is correct or not? I have a table in here. Okay. So you can see in here this input, right? Okay, I drop here. The port 1 data is from 3 and 19, 33 and 51. For the 8 is 115, 115 here. It should be work. Great. Okay, then you can save it. You can compile again. What? Why? Yeah, because we still didn't configure here. Okay, so and then we can go to the if B error. Then we need to put the end inside. I60 step is equal to 20. If any error while we executing the function block, we will jump to step 20. Then what we do in the step 20, we just copy same function block in here, then put here, we show, and then put here. Just put this one to false to turn off the function blocks, and then we can change back to step to 0. Okay, 0. So when we go back to 0, then we check the P enter to come is okay or not. If there's a error in the module, this one should not be turned on, so you'll not go with step 10. It should be a very simple loop. Then just compile, make sure no error. Great. Now we can start to create the process data. Okay, the first one is the process input data. Process input data VALID. And then UDS, we define UDS, right? UDS.dvs0 is equal to IOLINK dot what? W02 dot 0 dot W02 0. Then we just copy it. 1, 2, 3, 4, 5, 6, 7, 8, and then we can just 1, 0, 2, 4, 6, 8, A, C, E. And here we can just do same thing for 0, 2, 4, 6, 8, 10, 12, and 14. Great. And then we can configure the port 1. What is port 1? So go back to slide. Where's our slide? Where's my slide? Here. My slide. Port 1 is connecting to the mood switch, mood analog to IOLINK converter. So port 1. Why? Hey. Okay. Port 1 is mood analog to IOLINK converter. ERTR. Okay. And then how can do it here? We can how to do it here? Then we can just R32 port 1 dot current is equal to int to view. We need to change our input data first. Dot port 1 data to first work. Right after we change it to view, and we can divide it with 32767.0, and then we need to multiply 20 and then plus 4.0. I think I should not have error. Just check it. Okay. Then we'll need to port level is equal to this one same. Just copy this formula. Is multiply 100.0. Finish. Then we'll have a port 4. Port 4 is connecting the TURCK sensor. Port 4 TURCK 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 sensor UNSOR. So how to do it for? Then we have I60 port 4 process data. I think I make some mistake here. Why this one process data? It should be this one, right? 60 data. Yes, it should be this one. Okay, let's close it. I60 port 4 process data reverse is equal to IOLINK 103 dot port 4 0 is correct, and then we'll have a not revert data is equal to int to work IOLINK dot port 4 1. Great. Then we get the data. Then you go to the port 5. Port 5 is connect a NASUS electrical value. And then how to do this? In here we don't have only have output. So we have IOLINK 1.10. Oops, it's 104. Okay, now we need to define the IOLINK output data also. Go global and IOLINK 104, and then click in here. Structure types shows 104, and then go detail. This time to 500. Then we can open my Excel in here. Then it's output. It's 21834, and we will have 1566, and then we will have 829. Great, it should works. Okay, that's okay. Now you see the color change to blue. It means we assign the device inside. Then we close it. Then we can start to do it. IOLINK 104. Port 5 0 dot 0 is equal to some switch, in my case like 101 something, so say device. And then we will have I16 set point is equal to D11103. I think I did set this set point is correct, right? I60 set point I60. Okay, it's okay, no problem. And so what we need to do in here, then we need to IOLINK 104 dot port 5 dot port 5 0 dot 1 is equal to port 0. Then you can also use shift bit. I just show you the other ways to do it, because I'll show you the slide here again. Because for this one, no, for this one, the first bit is to control the value to on off, and from bit 1 to bit 8 is the PWM set point. So we need to shift it, or you need to put it one by one. In my case here, I put it one by one. So I copy it, paste 1 2 3 4 5 6 7 8. Then 1 2 3 4 5 6 7 7. Okay, it should be 1 2 3 4 5 6 7 8. Great, it's done. Then we'll go to next one. It's port 6, port 7. It's a mood IOLINK hub. Okay. So here that you need, I will get the input data first. So it should be input data UDD mood inputs dot B0 is equal to IOLINK 103 dot port 7 dot 0. Great. It works. At least I'm going to compile again. Make sure I didn't make any mistake. And then I just copy it to 16. 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6. Okay. Then I can change the bit access. Bit 1, bit 2, bit 3, bit 4, 5, 6, 7. Oops, 7, 8, 9, A, B, C, D, E, F. Then here bit 0, and then bit 1, and then bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8, bit 9, bit 8, bit 10, I think bit 8, right? Bit A, and then BB, and then have a BC, and here's BD, BE, and file is BF. Great. And then I would like to do the output data also. How to do this? And DUT move output dock pin. I'll use pin 6. I'll use B6, the 6 bit is equal to DFB D on 1 dock Q. And then IOLINK 103 dot port 7 dot 5 is equal to this one. Yes, great. Okay, it works. Then finally I will have a CONTRINEX sensors. So here's the CONTRINEX sensor size. UDT CONTRINEX sensor 1 dot, the bit 0 is equal to IOLINK 103 dot port 8. I think it's port 8, right? Port 8 0 dot 0, right? And then just compile it. No, oh cool. Why? Yeah, dot 1. Come on. Okay, I think I make some. Give me a second. Dot port 8. I have it here. 0 dot 0. Dot 1 dot 0. It should work. Let me compile again. Make sure no error in here. Great. And then just copy and then paste. Because why? I would like to show the slide again. Because bit 0, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So how to do it? Say for 1, 2, 3, 4, 5, 6, 7, 8. Great. Then B1. And then we'll have a B2, B3, B4, B5, B6, B7, B8. B7. Oh, okay, we don't have B8. Okay. Yeah, sure. We don't have B8. And then I would like to get the scaling value. BENO is ENO. Temp is equal to WAND, and then true. I put true, and then I will link 103 dot port 8 1, and then 60 sharp FF00, and then send it to D1000, the sum buffer. Why FF00? Because this one, the scaling value actually is in here, is by 0 by 1. So I would like to take out this one, and then I would like to take out this one and then shift it, just like what we do before. And then so what I'm doing here is after that you can use SHR, and D1111 is equal to SHR E. It should be true, BENO temp, BENO temp, and D1000, and then I'll shift 8-bit. Okay, and then UDT CONTRINEX sensor 1 dot our scan value is equal to what? Equal to IND2 real for D1001, and then UDT sensor 1 dot measure value is equal to, it needs some calculation but very simple, IND2 real. Then you have IOLINK data, right? Is dot port 8 this 0, and then over 163 84.0 and then multiply 110.0, 110.0. Great. Okay, let's compile it, make sure no error. Great. And then after that I would like to configure the VBR data. VBR is the data in here. In VBR is here. Okay. Then UDD VERR dot 0 is equal to IOLINK 103.VERR.0. That's why I told you that function block using functions is better. So here, if you have 8 of IOLINK master, you have to program it 8 times. But you can use functions to make it more easy. And yeah, just copy it to 16 time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. A, B, C, D, E, F. And here is 1. And here is 2. And here is 3. And here is 4. And just do it to the 8 time. 5. That's why I told you that a good naming is very important for you to program to make the program B8, right? B8. And then we have B9. And then we have BA. And then we have BB. Then we have BC. And then we have BD. And then we have BE. And then we have BF. Great. Okay. And after that, I would like to make the point diagnostics. The port diagnostics DIAGNOSTIC. Oh, how to do it? Do you remember that we created functions for that, right? So we can directly use the functions. How to do that? It will do like this. TURCK port diagnostics 1 is equal to FC TURCK get event out in diagnostics. That we can we have 4 parameters, right? You have a yen is a B start to com, and then we will have I think this one should not be here. Oops. This one should not be here. It should be here. Yes. And we will have a B yen temp, and then we would like to put the data inside. It should be IOLINK 103 dot port 1. Great. Okay, from here just compile the code, make sure no error inside. Okay, and then we can copy it. 1, 2. Just put it more beautiful. And then 3, 4. Okay. And then we can copy it one more time. Okay, and then make it more clearly. And then finally have okay. And then we can just change the numbers of array. 1, 2, 3, 4, 5, 6, 7, 8. And here same, do the same things. 1, 2. Hey, why don't I have 2? Don't. Ah, my spelling error. Come on. 3, 4, 5, 6, 7, and then 8. Okay, great. all this stuff is done. Compile, make sure no error. Great. And then finally, what we need to do is we need to figure out the event. How to figure out the event? Event. I would like just call one times. We can call any time so you need. Event. I would like to use the event 1 is equal to fc TURCK get events. They have different parameters, right? The first one is b start to com, and then your next one is called b temp. It's just the output, and then you put the data inside. It should be IOLINK 103 dot IOLINK event, the first one. IOLINK event. Wait, no. Dot IOLINK event. Okay, yeah, sure. And then just close it and make sure no error. Compile again. Great. Okay. Finally, we need to call the function block to send the data to our IOLINK master from TURCK with Ethernet IP. How to do it? FB class set. Then right click, display tempo, and then just put it to beautiful, and then here, then here, and then here. Let's put it to easy to modify in the future. No, here. Yes. Okay. And then this one is b started to com. For the module, it should be EIP91_1, and connection number is I connection number, and output data is start from 500. Do you remember we set the IOLINK global data from 500 here? So that's why reason we just set 500 here. Close it. And BENO temp BENO, and then this one's BOK, and here is B error, and here is U error ID, and here is U status ID. Great. Finally, compile, make sure no error. Then you see all this is changed to right text, so it means that all the data is using here. Then we can save our project, then we can download it. Plus this button to write PLC, and then choose all, and then execute it. Okay, select files will not be converted. Why? Then we can try again. Check again. Function is okay. Let me check why I cannot download the program. Okay, so let me review again and save it, and then oops, not this one, and then download the program, select all, execute, write it yes to all, and just wait a second. Turn to write mode, and then close it, and then monitor it, and see what happened here. Step is changed to 10. It's okay without any error. Then if you see here, that is some value in here. I don't know why it's this 0%. Why? Port 10, it changed to 100. Why? Port 10. Okay, let me check just a second. Okay, I think I need to restart my PLC, and then after I reset my PLC, it should works. And here's okay, and you see some data is shown in here. Then let me close here a little bit small. Wait a second. Yeah, sure. And you see some data is getting here, and I'll check it. Just a second. And I will turn on the camera now to show you all the data one by one. The first one I would like to show you is the analog converter to IOLINK converter, and here is my camera. Here's my camera, and I should a little bit small in here. Then I will try to move this level sensor. Then you can see the current, the change. Now, just me a second. Okay, you can see the level and the current change. So this one's okay. And the next one I'll show you is the TURCK sensor. Okay, I open the camera again. Just me a second. Okay, the TURCK sensor also works. And then here is the electrical valve that comes from Nexus. So I just turn it on. Then you see now it changed green, and then I turn it off. Then you change to pink again. And here is the Moodle IOLINK hub. Then I open here. Then you see the lamp is turning on off here. Then I'll turn on the switch. Just give me a second. Then you see the switch also work. And what I still have? The contact sensors. I use the screwdriver. Just give me a second. I think it should be better to this side. Okay. Okay, you see the sensor is also working. And then I'll show you the diagnostics. So how to do it. I will turn on, I will monitor this one, right click, register to watch window 1. And then here, I will open it. Open all the datas here, and then just let you see. Okay, so now I will release this one, the analog converter, the analog input side. Then you see the error. It's really there's a error show get from the Moodle IOLINK converter. Just a second. Okay, now you see they have a, I think it's orange LED. It means there's some error. Actually, the error is because there's no analog input come from this side. Then you see the port 1 have error. The converter is 288 and the line code is 6150. And then for here, then you see the applications have error. It's device, it's warning. Now it's happening. So now I return it. Just a second. Okay, now you see no error happen anymore, so it works. And then finally, I'll show you some web server functions of the TURCK IOLINK master. So I open Firefox, and then go to web server. I think it's the IP address is 121, right? Oh, it's 1. Not 5. It's 1.1.1. Okay. Okay, so first of all, I need to log in it with password. I don't want to change it. And then there's a very powerful tools, powerful website. You can configure everything inside the web server. For example, now you know the HTML now is rotate, and the hardware version, software version, and the POVNet, Ethernet IP, and version here. And then you can go to parameters. You can change the IP address. You can change the Modbus TCP/IP configurations. You can set the AGRI to use, and also the Diagnostics to check all the port data, Ethernet port data, and you have a event log to show all the actions is happened inside the TURCK. It's relating to the TURCK IOLINK controller, IOLINK master. Then you have parameters. You can directly set the parameters of each port. Then, for example, different DI. For example, this one is without modifications, and this one has need to set swap or no need to swap. And you can check the IP input of each data, also output. This one's very powerful, and also so other pages, so IODD configurators, also very good tools for you. You can directly link the IODD file. So I'll say this. For example, I unlink the file here. Then now it's a generic file. We don't know what is here. You can go to web search. Then just wait a second. Then you directly get the IOD file directly, and then after that you can also download from your PC. But if your PC connecting to the internet, you can directly use this way. Then you can know all the parameters inside. You can set the parameters. Then you will get the informations. You get the process data for now. Then you will you can also get the process data structure in here. What kind of events happening here, and what is the event history, and even the wiring diagrams. And for the documents, then you can go ahead and click here to go to online documentations, and also you can go to Ethernet IP addressing mapping and Modbus TCP mapping, memory mapping. That's very great for you to do it with when you're programming. So here is the page in here. You can download all the information. For example, you can download the conversion software. You can also download the EDS file. You can download the datasheet. You can download the menu. All the information you need to use, you can download here. So I think my tutorial is enough. I'm sorry that I think it's very long tutorials that I hope you know how to use Mitsubishi GXbox with their Ethernet IP modules. You know how to configure with TURCK IOLINK master module. I hope you know some concepts about how to create the functions and construction types in Mitsubishi GXbox 3. I hope I can see you next video, and please have a good day. Okay, see you again. And if you like my video, please like it, subscribe it, and share it to every people. And if you have any problems, please leave a comment in the below. I hope I can see you in next video. So have a good day. Bye bye.